All right. So this time when we look at Daniel Tiger, again, this is Daniel Tiger, and Katerina Kitty Cat, and I ask the same question. Who is moving faster? Okay. But we're going to look at a different type of speed. Last time, we looked at their rotational velocity. This time, we are going to look at their linear velocity or tangential velocity. Their linear velocity or tangential velocity, instead of being measured in rotations per second, is going to be measured in meters per second, just like before when we found the velocity of things moving in straight lines. That's why it's sometimes called the linear velocity. And what this is telling us is how fast they're going if they were going in a straight line, or how far they're going each second in centimeters. So how many centimeters they're traveling or how many meters they're traveling. Right now, I'm just going to do this one in centimeters. Okay. In order to figure out their tangential velocity, and we call it that because, again, it's meters per second, but also if I make this go fast enough, they fly off. And if you watch them when they fly off at what we call a tangent. In your geometry class, you learned that a tangent to the circle is a line that touches a circle at one point. So I think Katerina fell off over here. So if this is the circle, our disc is rotating that direction. Okay, Daniel Tiger probably fell off right about here. He flew off at a tangent and landed somewhere in here. Katerina probably fell off somewhere around in here. So she flew off at a tangent and landed somewhere over there. So tangent means you fly off and you continue going in the same direction you were going at that point. So it was kind of going down and to the left, so it continued that way. She was just kind of going up, so she continued going that way. And then they hit the table and stopped eventually, okay? But tangent, when you were in geometry, your lines went both directions, okay? Still, tangent technically goes both directions. But if we're going this way, we're going to fly off in that direction. We won't come back. We're not going to reverse directions when we fly off. So that is what tangent means. So now, that's why it's sometimes called the tangential, why people call it the tangential velocity. But sometimes we also just call it the linear velocity. So if you see those, it could be called either. And again, it's a distance, how far they go in a time. So we're going to get this going, and we're going to time how long it takes them to go around once. I'm going to use this as my starting point again. But I need to know what distance they went, okay? Well, they're traveling in a circle. And the length for going around one time in a circle, if you remember from your geometry class, is called the circumference of a circle. Now, I know this is not a perfect circle, but pretend like I've got a perfect circle here, okay? This length around a circle is called the circumference. So if I time them for going around one time, then to find the distance that Daniel Tiger goes, I need to find his circumference. And you should know from geometry, the circumference is equal to 2 pi times the radius, okay? And in this class, you can use the pi button on your calculator, or you can use the number 3.14. Now, in this case, the radius is 5 centimeters. So I should get a circumference for Daniel Tiger of 31.4 centimeters. So let's go ahead and see if his string is about that long. So take our string, and we should get around the 31 centimeters, okay? Again, mine wasn't a perfect circle, but we should be getting close to that, okay? So the thing you notice, though, this was Daniel Tiger's string, okay? And here is Katerina Kitty Cat. I had her out here at 10. So her string, to find her circumference, and again, I know it's not a perfect circle. It's just for a demonstration, all right? Her string, if we look at it, when we line it out, take it off and lay it down on a line, is clearly much longer than Daniel Tiger's was, okay? So she's going a further distance, and we could find hers, okay, by doing her circumference. So the circumference for Katerina would be 2 pi times her radius, and her radius was 10. And I'm not going to finish that one off for you. I'm going to let you type that into your calculator and get the circumference for Katerina Kitty Cat. So that will be her circumference. And now, to figure out their speed, their tangential velocity, or their linear velocity, whichever one you'd like to call it, first we need to get them going. So I'm going to go ahead and get them going. So they're going, Daniel Tiger's going 31.4 centimeters, but how long does it take him to go that far? So we need to time how long it takes to go one time around. So we're going to go ahead and start our stopwatch the next time that Daniel Tiger passes this point, and then we'll stop it when it gets back. Ready? And go. Stop. Okay. And then if you want to do Katerina Kitty Cat, you could do the same one because they're moving together. They're past that point at the same time. Okay. So use the same time for both of them, but they have different distances, and therefore we should get different tangential velocities.